So, number one, we're simplifying. Again, we want to make sure we're reading the directions. Number one says to simplify. Number two says to estimate. So even though all these questions look like they're asking the same thing, if you just look at the square root, we're going to be doing a very different thing in number two, right? So in number 1a, I've got root 36 over root 100. I can split this up into two separate square roots. What's the square root of 36 going to give me? 6. What about the square root of 100? 10. Can I simplify 6 over 10 any further? Yes. What two numbers multiply to give me 6? 3 times 2. What about 10? 5 times 2. What can I cancel out here on the top and bottom? 2's go away, and I'm left with 3 over 5. Plus or minus in the front. There's my answer. All right, B, just like our warm-up, I've got a negative sign in front. 25 is 5 times 5. So my answer is just negative 5, right? C, again, just like the warm-up, 24 is not a perfect square. I can factor tree this out. What two numbers multiply to give me 24? 6 and 4. Good morning. 6 is 2 times 3. 4 is 2 times 2. Thank you. I'm going to set this up. 2 times 2 times 2 times 3. Is there any pairs I can circle up here? Pair of 2's, good. Bring those out in front. What gets left behind? 2 and a 3. So my 2 comes out in front. I've still got a square root. What's going to be underneath the square root? 6. Anything else? Perfect. Plus or minus 2 root 6. Great catch. All right, so if you see, we always use a plus or minus unless we just have a minus in the front. Now, number 2, we're not going to break this down. We're not going to simplify. We're going to estimate. What's the closest perfect square to 104? 100. What's that? The closest perfect square to 104? Oh, yeah, that's fine. So, the perfect squares are the big numbers that are highlighted, right? So if I'm looking for 104, well, 100 is the closest to that, and it's less. Okay, so that'll be equal to 10. The next perfect square is 121. That's equal to 11. So root 104 is between 10 and 11. You don't have to do all that. I'm just showing how we got it. The square root of 55, it's probably closest to 49. Square root of 49 is 7. 64 on the other side gives me 8. So we're somewhere between 7 and 8. Please make sure you're actually writing between here. It adds important information. 231 is a little less than 256, a little more than 225. So this is between 15 and 16. Okay. All right. Now, if we're trying to figure out if something's rational or irrational, remember, irrational numbers are imperfect squares and ugly decimals. So if I look at 3a, give me a thumbs up if that's rational, thumbs down if that's irrational. What do you guys think for 3a? Root 45. I see some thumbs down. I see people not putting their thumbs anywhere. Okay, good. Thumbs down. This is irrational. Why is it irrational? Because it's an imperfect square. Exactly. We can't break this down all the way. If we even tried to simplify this, which we can, we'd get 3 root 5, which we cannot write as a fraction. This is irrational. Same thing with B. Yes or no? Give me a thumbs up for rational, thumbs down for irrational. Very quick. I'm not going to call you out and say, oh, answer this question, but I do want to see your thumbs. Good. Thumbs up. This is rational. What is the negative square root of 9? Negative 3. That's obviously a rational number. It's also a integer and a real number. That's it. What about C? Thumbs up, thumbs down. What do we think? That's the easy one for C. Ooh, maybe not so easy. I see some thumbs sideways. Maybe that means I don't know. What do you guys think of this decimal? Is that a nice looking decimal or no? No, that is irrational. Again, if you get stuck on this, just say, can I write this as a fraction? Bless you. This decimal, I cannot write as a fraction. Negative 3, well, I could write that as negative 3 over 1. There's a fraction. 3 root 5, cannot write that as a fraction. Fraction, rational, fractional. All right? Think about that if you get stuck. Number 4, solve the following equations for the given variable. Be sure to find both solutions. What does that mean? What does it mean to find both solutions? What does my answer need to have on it? Plus or minus. Both solutions means a positive solution and a negative solution, just like we had up here. And like you were saying, we also need the variable. So x squared equals 169. What do I want to do to both sides to get x all by itself? Take the square root. What's the square root of 169? 13. So x is equal to plus or minus 13. Nice and easy. We do want the variable, right? If I'm simplifying, I just need the number. If I'm solving, I need the variable because we're dealing with an equation. For b, same thing, square root both sides. The square root of b squared is just b. What's the square root of 64? Just 8 plus or minus 8. And c squared, I'm going to square root that. Square root 225. The square root and the 2 cancel out. What's the square root of 225? Just 15? Plus or minus 15. We got to remember the plus or minus. That's what both solutions means. Any questions on 1 through 4 before we move on to the fun stuff? All right. Distance formula always gets people tripped up. We just have to follow the process. How do we begin the process to do this? We got to label. x1, y1. x2, y2. My distance formula looks like this. x2 minus x1 squared plus y2 minus y1 squared equals d squared. Not just d, d squared. I'm going to set this up without my variables so I can easily plug everything in. What am I going to plug in for x2? 7. What am I going to plug in for x1? 1. What about y2? And y1? 5. 7 minus 1 gives me 6. 8 minus 5 gives me 3. Now I'm going to square them, add them, take the square root. What is 6 squared? What about 3 squared? Add them together, what do I get? 45. What happened? Is it not 45? Yeah, it is. 45. Is that my distance, 45 units? No, what do I have to do now? Square root both sides. Can I simplify the square root of 45? I can. It's not a perfect square, but I can still simplify it. 45, just like in the warm-up, is 9 times 5. 9 is 3 times 3. So D is equal to the root of 3 times 3 times 5. Is there any pairs I can circle up here? Pair of 3's comes out. What gets left behind? 5. D is equal to 3 root 5. Is that it?
No.
What do I need on the end? Units. Do I need a plus or minus here? No, why not? Because distance cannot be negative. So no plus or minus, but I do need units. It's either or, one or the other. All right? I know it's a little confusing, but hopefully that's not too bad. Let's do the same thing with B. x1, y1, x2, y2. D squared is equal to 11 minus negative 2 squared plus 1 minus 7 squared.
2 plus
Say that again, Zaris.
2 plus
2 plus 2 minus signs make a what? A big plus. What's 11 plus 2? 13. What about 1 minus 7? Negative 6. Doesn't really matter, though, if it's negative or not. What does 13 squared give us? Ooh, that's 13 times 2. 13 squared is 13 times 13. 169. What about negative 6 squared? What is that going to give us? What's negative 6 times negative 6? Positive 36. Right? Yes.
I think weren't you supposed to do 11 minus 7?
Ah, you're right. x2 minus x1, 11 minus 7. Good catch. See how easy it is to mess this up? I was feeling pretty confident about that. I was like, oh, I got two numbers, I square them. Then I would get, what, 205, and then that's weird, but x2 minus x1, good, is 11 minus 7 plus y2 minus y1. Add those together to get 3. Subtract those to get 4. I get 16 plus 9 gives me 25. Square root both sides. D is equal to 5 units. Great catch. All right, so take a look at that. Double check your steps with mine. Make sure everything looks all good. Ignore my mistake. Any questions on the distance formula? When we're done with this, let's take a look at the back. Some triangle talk now. We got to figure out, do these sides form a right triangle? This is our converse of the Pythagorean theorem. So I take all three of my sides, plug them into a squared plus b squared equals c squared. See if I get a true statement or a false statement. Now, it doesn't matter what I plug in for a or b, but what am I going to plug in for c here? The highest number, which is 10. So I'll call 8 my a, 9 my b, 10 my c. All right, what is 8 squared? What about 9 squared? What about 10 squared? All right, I add my left side together and get what? Definitely not 100, 145. Those are not equal, so what's my answer? No, false is not my answer. Read the question. Do the following side lengths form a right triangle? There's only two possible answers, yes or no. True or false would not be answers to this question. We get a false statement, the answer is no. They do not form a right triangle. Let's take a look at B. What am I going to plug in for C on this second problem? 10 again. 6 squared plus 8 squared equals 10 squared. 36 plus 64 equals 100. What is 36 plus 64? 100. That is true, so what's my answer? Yes, this does form. That doesn't say yes, it says yes. Yes, there we go. You know what I mean. Yeah. The test is 20 questions. Yeah. Now this is 10 questions, but really it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the study guide's 21 questions, the test is 20 questions. It's the same. No, tests are always on paper. Unless it's a final. Because I'm not trying to grade all that. Number 7, find the missing side lengths for the following triangles. This is basically the exact same thing as what we just did, except we don't know what one of the letters is. So this actually confused a lot of people when we first took a look at this study guide. But I'm just going to do a squared plus b squared equals c squared. And I don't know what c is, so that's what I'm going to solve for. All right? What does 2 squared give me? What about 6 squared? Add those together, and what do I get? What do I do now? Square root both sides. Is 40 a perfect square? No, but I can break it up. What two numbers multiply to give me 40? 4 and 10. What about 10? 2 and 5. 4 is, of course, 2 and 2. So I've got a pair of 2's, a 2 and a 5 left over. C is equal to 2 root 10. Okay, so that's it for solving for the hypotenuse that's missing. But in part B, we're missing a leg. So we've got a squared plus b squared, which is 4, equals c squared, which is 5. Just plugging the letters in where they go. 4 squared gives me 16. 5 squared gives me 25. I'm going to split my equal sign so that I can do what on both sides? Subtract 16. What's 25 minus 16? 9. Square root both sides, and what do we get? 3. Now these last 3 problems we went over on the guided practice yesterday. Hopefully we're feeling more confident with this. Who could tell me, what do I need to do in number 8? Starts with the C. It's a verb. You learn how to do it in like 1st grade. Counts. That's all we got to do is count. I need to find the length of my hypotenuse. The hypotenuse is a diagonal line on a graph. So I need to find the length of my 2 legs. I can do that by counting. My vertical leg is 1, 2, 3, 4 units. My horizontal leg is 1, 2, 3, 4, 5 units. 4 squared plus 5 squared equals c squared. A and B are my legs. C is the hypotenuse that I'm trying to find. 4 squared gives me 16. 5 squared gives me 25. What happens when I add 16 and 25? I get 41. Square root both sides. Is 41 a perfect square? No. Can I break down 41? No. So what is C equal to? Just 41, right?
Square root.
Square root of 41. Units. We're talking about a graph. We need to make sure we have units. Now, if we're just talking about a generic triangle like the two questions above, you don't need to put units. You can if you want. I'm not going to be picky about that. But if we're using a graph, I do want to see units on your answer. Root 41 is all we can get. All right? Number 9, a square poster is 20 inches tall. Find the diagonal length. Here's my square. I have to draw my diagram. There's my diagonal length. I'll call it C. If my square poster is 20 inches tall, how wide is it? 20. 20 squared plus 20 squared equals C squared. What would 20 squared give me? 400 plus 400 equals C squared. That gives me 800 equals C squared. Square root both sides. How can I break up 800? 400 times 2. You could do a whole bunch of different things, but I'm going to use my shortcut here. How can I break up 400? 20 times 20. So the root of 800 is 20 times 20 times 2. Is there any pairs in there I can circle up? Pair of 20s, what gets left behind? 2. C is equal to 20 root 2 what? Not units, inches. When we have specific units, like we do right there, we want to include those specific units in our answer. Don't just put units, put the actual units. Inches. Okay, hopefully you've noticed the square pattern by now. Finally, number 10, base of a shed that is 9 feet tall has a ladder leaning against it. The base of this ladder is 12 feet away from the base of the shed. How tall is the ladder? So what we don't know is the length of the ladder. I'm gonna draw my diagram. There's my shed or my building. There's my ladder. There's my base. The shed itself is 9 feet tall. The distance between each base is 12 feet. So what equation can I set up here? Someone want to help me out? Perfect. 9 squared plus 12 squared equals C squared. Gives me 81 plus 144 equals C squared. What's 81 plus 144? 225 equals C squared. Square root both sides. And C is equal to what? 15 what? Inches? Feet. Feet. If you don't know what units to use, just read the question again. 15 feet is what we get. We have tons of ladder problems to use on the test. We've got this one. We've got 2 of them on the guided practice. We got 1 of them in our notebook. We got 2 of them on worksheet 63. So if you remember, there's 2 different scenarios. Either we don't know the C or we don't know the let. That changes how we set things up. Roz, question. How did I get 20 and not 60? Why did I get 20? So it's 20 inches tall, right? So 20 by 20. 20 squared plus 20 squared gives me 400 plus 400. We add those together and get 800. And then when I split that up, again, I'm just looking at the steps above. So we got 800 by doing 400 times 2. And we got 400 by doing 20 times 20. So I've got a pair of 20s a 2 left over. My pair of 20s comes out. My 2 stays behind. This is a 2. Right here? When I do right here? Oh, up here? Oh, yeah, that's a 2. That's an ugly 2. I'm sorry. But yes, it's a 2. Sorry. My bad. Yes, that is 20 times 20. Ida. Square root of 41 units, not 41 units. If this leg is 5, this leg is 4, and this leg is 41, that defies our triangle laws, right? Yes, 41 is larger than 5 and 4, but 4 plus 5 has to be larger than my C, my hypotenuse. Square root of 41 is in between 6 and 7, which is greater than 4. It's greater than 5, but 4 plus 5 is greater than in between 6 and 7. Yeah, so do not drop the square root. If I can't simplify my number, I keep the whole thing in the square root. Devin. Hold on, we're almost done with this. Any other questions? Those are great questions, you two. Anything else we can talk about? Okay.